Hi class, so Assalamualaikum and good day everyone. Okay, so for this week we enter new topics, but we are still in the same chapter. Okay, we see chapter for what you call multiple integral. So we have passed double integral. We already done before your midterm break. You have done what triple integral, rectangular and also not rectangular. Okay. Then for today topics, we will enter the new one, which is okay. Before that, if you still remember that for double integral, you already also learn Cartesian form. Cartesian form means in term of x, y, z, is it? And also polar integral, okay? And so now for this week, for triple, of course, they also have similar like polar, but we name it as, okay, we have two, for triple integral we have two. Okay, we call it as what I call cylindrical coordinates and also spherical coordinates. Okay, so these two is quite similar. Not these two, I think for cylindrical it's quite similar like the polar integral in double integral. Okay, so for triple we have two type of this. We call it cylindrical and also spherical. So if you can see the keyword here for cylindrical, so it means that the shape that you get, okay, because it's 3D, is it? Okay, triple integral we will get a shape in 3D form because they have 3 axes. So the shape is like cylinder, okay, cylinder. Okay, the shape is something like cylinder. And spherical, the shape is like sphere, okay, sphere lah, okay, is because it's a 3D. If it's 2D, it's just a circle, but if it's 3D, so it become a sphere, okay. Alright class, so okay, I will go one by one. First, I will go to the cylindrical coordinate first. Okay, cylindrical coordinates. Okay, basically, okay, I just give you some intro lah. Okay, some intro. So we have 3 axes here, right? Okay, so basically, cylindrical coordinates, they will be have an it's no longer x, y, z. It will be a new, what we call the new variable that we will use. Okay, we will use r and theta. Okay, it's similar like polar, is it? Okay, r and theta. So theta, of course, we know that theta is the what you call angle. Okay, the angle from the axis to the point. Okay, to the point. Okay, right. So basically, the variable that involved in cylindrical coordinate is r, theta, and also z. Okay, because it's triple, is it? So kalau for example, if for double integral before, we just only have r and theta, but now it's a triple integral, so they must have 3 variable. So it's r, theta, and also z. Okay, so r and theta are polar coordinates. Okay, it's a polar coordinates. Okay, that you learn in the polar integral in double integral before this, and of course, z is a what you call the rectangular vertical coordinates here. Okay, alright. Okay, so you need a substitution. Okay, because the question will given to you in terms of Cartesian coordinates. So you need to apply or you need to substitute that x, y, z, and it will become the cylindrical coordinates later. So the substitution that you need here, okay, so I just write first the what you call the Cartesian, okay, dx, dy, dz. You will be change it, it will become, okay, it will become dz. Okay, dz is remain as dz lah because z is still remain as z. Okay, and then we have r dr d theta as a balance here. So you can see that r dr d theta, this one is a polar integration. Okay, polar coordinate just before this, and they have dz. So about the sequence, actually it doesn't matter. You want to start first with dz also can. You want to start with d theta also can. You want to start with r dr theta also can. It doesn't matter about the sequence, but make sure the limit here it must follow lah, okay, must follow the integral here. Okay, so we will change the x dy dz, it's become this one. Okay, and then of course lah, it's similar like polar. So x you will replace it with r cos theta, y you will replace with r sin theta, and z we will remain as z. Okay, remain sama. Okay, z dia akan kekal lah. Okay, z we will maintain. Okay, so now okay, I will explain for spherical. Then in the next video I will show you the example later. Okay, so for cylindrical now, for spherical coordinates. Okay, yeah, basically it's similar lah. It's a triple it's a triple integral. So they will have 3 axes here. Okay, then so I just give what we call the figure ataupun yeah, bayangan lah how the what we call the graph. Okay, so this is the point. Okay, alright, the point will be, okay, P as a point. So the variable that we involve here is rho. Okay, it's a rho, and this is a phi, and this is theta. Okay, class? Alright, sorry for the noise. Okay. Okay, because now we are work from home kan, so macam-macam bunyi ada. Alright, so we back to this. So we have rho, phi, and theta. Okay, so theta, of course lah, theta is an angle. Okay, alright. Okay, so what's about phi and rho? So this is rho, and this is phi. Okay, maybe it's something new for you. So rho and phi. Okay, so rho. Okay, rho is the distance from P to the origin. Okay, it's a distance from P to the origin. So this is a rho. Okay, here is a rho. And how about phi? Phi is the angle. Okay, phi also is angle, but it's between the positive z axis with the line of the from the origin to the point P. So this is the line from origin to P, and this is x axis. So this is your phi here. Okay, and theta is an angle. Okay, theta is the angle from the cylindrical coordinates. Okay, so now, yeah, if like you can see here, we have a new variable that involved. It's no longer x, y, z. It will be rho, phi, theta. So now, what's the substitution that you need to make it here? Okay, so let's say we have here dx, dy, dz. So you will change it become, what will you change it? It will become phi square. This is rho square sin phi. Okay, d rho, d phi, d phi, and d theta. Yeah, this one. Okay, the x, dy, dz, you will change it become rho square sin phi, d rho, d phi, d theta. And for start from this one, okay, you can just swap. I mean, you can just start from d theta and then d phi, d rho, or d phi, d rho. Yeah, it doesn't matter about the sequence, but make sure this is there. Okay, you must bring this one together. Okay, like same lah, like for cylindrical just now, you must bring this r together. Okay, okay, r is to attach. Okay, r is attached to dr. Okay, attached. So means for this one also must be attached to this one. Okay. Alright, class. So this is the what you call the intro lah, the intro for cylindrical coordinates, and also for the spherical coordinates, and also the variable that exists for both. Okay, so later on in the next video I will give you example and I will show you how to answer it. Okay, alright, dah.